Hello everyone. So today we're going to look at a problem of KVPY 2021. The question is find the number of positive integers ordered pairs x and y for which they are satisfying this given equation. The given equation is 2 raised to power x plus 3 raised to power y is equal to 5 raised to power xy. And feel free to pause the video because the four options are in front of you. Okay, so let's try the problem. So the problem is 2 raised to power x plus 3 raised to power y is equal to 5 raised to power xy. So when I look into this equation, the first thing I can see is I can approach analytically. So the analytical approach will be if I take any term on the left hand side and if I take log, okay, then I'll not get the solutions. So what I can do best here is I can go by hit and trial. But with hit and trial, the problem is maybe there are infinite solutions. Okay, so one thing I can do here is let's say x and y are positive integers, right? Are positive integers. If x and y are positive integers, then there might be infinite order pairs. So let's say the least value of y is equal to 1. The least value of y. So for y is equal to 1, I'll check the equation. The equation will become 2 raised to power of x plus 3 raised to power y, that is 1, is equal to 5 raised to power xy, that is 5 raised to power of x. So for this, maybe I'll get solutions. Okay, so the y value is varying from 1 to infinity. Maybe there are infinite order pairs. So we'll check for y is equal to 1 there is a solution or not. So according to that, we'll decide the ordered pair, because in question they are asking number of ordered pair, they are not asking the value of x. Okay, this thing you have to keep in mind. Now let's start with this equation. So given this equation, 2 raised to power of x plus 3 is equal to 5 raised to power of x. Again, if you solve analytically, then I warn you, your black hairs will become white, and if you already have white hairs, then no offense, because there is no way you can find the solution of this equation analytically. Now they are asking number of solutions. For number of solutions, I can check graphically. That is the best approach I can do here, because they are only concerned about number of solutions. So let's start. So if I put x, let's say this is my first function f of x and this is my second function g of x. If I plot these two functions individually and if I find the number of point of intersection, then that is my solution, right? So let's start. So I'll plot these two on a x-axis and y-axis. So this is my x-axis and y-axis. Let's say for x is equal to 0. Okay, for x is equal to 0, f of x will become, here f of x will become 2 raised to power 0 plus 1, that is 4. And for x is equal to 0, 5 raised to power of x, that is g of x, will give me 1. So now let's draw the graphs. Okay, so we'll get a better idea for the graphs. So I'm drawing 2 raised to power of x plus 3. 2 raised to power of x plus 3 is passing through 0 comma 4. So my first graph is something like this. Okay, exponential increasing, obviously. Now second graph, g of x. Now g of x is passing through 0 comma 1. It's directly visible. So 0 comma 1 is somewhere here. Obviously 5 raised to power of x will be below 2 raised to power of x plus 3. So it will go like this. Now once the value of x increases more than 1, then the graph of 5 raised to power of x will cut the graph of 2 raised to power of x plus 3 at some point. Now I'm not concerned about what is the value of x. Why? Because they are asking the number of solutions. So yes, for y is equal to 1, we'll get one solution. Similarly, maybe there are other values of y for which we'll get the solutions. Okay, so for y is equal to 1 and x some value x1, let's say we got the solution, so I got one ordered pair. Now for next y is equal to 2, I'll check. So for y is equal to 2, I'll get the equation as, this equation as 2 raised to power of x plus 3 raised to power 2, that is 9, is equal to 5 raised to power xy, that is 5 raised to power 2x, right? So we'll get this as 2 raised to power of x plus 9 is equal to, I can write this as 25 raised to power of x. Now we'll check the values of x. The function, let's say this function is f of x and this function is g of x. Now I'm only concerned about the number of solutions, so I'll draw the graph and I'll check graphically at how many points they are cutting. That is my total number of solution. So for x is equal to 0, f of x is equal to 10, and for x is equal to 0, g of x is equal to 1. So I'll get a better idea. Now I'm going to draw f of x and g of x on the x-axis and y-axis. So my f of x will look like this. So f of x I'm drawing with red color, and it is passing through 0 comma 10 somewhere here, and g of x is passing through 0 comma 1 somewhere here. Now let's draw f of x here. So f of x will be something like this, exponential increasing, okay, up to infinity. Now g of x, let's talk about g of x. G of x is passing through 0 comma 1. So 0 comma 1. Now 0 comma 1 is something like this. It is again exponential 25 raised to power of x. Now you can check for x greater than 1, this values to the 25 raised to power of x obviously greater than 2 raised to power x plus 9 for some values. Okay, so at some point it will be above, then f of x, it's clearly visible, and in this manner we'll get one solution every time. Okay, so for this case y is equal to 2, we got one solution, that is, let's say x2. I'm not concerned about x2. Why? Because they are asking number of solutions. So for y is equal to 2, I'll get solution. Similarly, if I do the same thing for y is equal to 3, 4, 5, 6, so on up to infinity, I'll get solution for individual y values and corresponding to some x values. So here our answer will be number of solutions will be infinity. So this is our answer, and that will be all for this video, and thank you.